The objective of this lesson is to compare two fractions by selecting an appropriate strategy. In previous lessons, students learned several strategies for comparing fractions. In this lesson, we will review these strategies and determine appropriate strategies for different situations. The four strategies we will review in this lesson are using 1/2 as a benchmark, using 0 and 1 as benchmarks, comparing by creating common denominators, and comparing by creating common numerators. Some comparison strategies can be used in nearly any circumstance, and not every pair of fractions will have only one appropriate strategy, but we will find that selecting an appropriate strategy will make comparisons more evident. The first pair of fractions we will compare are 1/6 and 6/6. These two fractions could be compared directly as they already have the same denominator, or they could be compared by using 0 and 1 as benchmarks. By drawing a visual representation of each fraction, we can see that 6/6 is closest to the benchmark of 1 as it is equivalent to 1. 1/6, on the other hand, is closer to the benchmark of 0. Since each fraction is closer to a different benchmark, we can use the benchmark values to compare the fractions. 0 is less than 1, therefore 1/6, while greater than 0, is less than 6/6. Our second pair of fractions are 15/10 and 3/5. Neither the numerator nor the denominator are already the same, but as we look closely, we can recognize that the denominator of 5 is a factor of the denominator of 10. With this relationship, we can multiply one fraction to alter it to have the same denominator as the other fraction. In this case, we will multiply 3/5 by 2. 3 multiplied by 2 in the numerator is 6, and 5 multiplied by 2 in the denominator is 10. Since we have multiplied both the numerator and the denominator by the same number, we have created an equivalent fraction. Since the denominators are now the same, we can more easily compare the fractions. Both fractions are now represented as a number of tenths. Therefore, the larger numerator represents the larger fraction. 15/10 is greater than 6/10, since 15 is greater than 6. We can check our reasoning with a visual representation in which we can easily see that 15/10 is greater than 6/10, or 3/5. Our next pair of fractions are 6/12 and 3/6. As we examine each fraction, we could use a number of strategies to compare them. Creating common denominators or numerators are both a possibility. But given that the numerator of each is exactly half the denominator, we can recall our previous lesson on using 1/2 as a benchmark. In that lesson, we proved that any fraction with a numerator exactly half the denominator is equivalent to 1/2. This means that both 6/12 and 3/6 are equivalent to 1/2, which further means they are equivalent to each other. Our final pair of fractions are 2/5 and 4/8. The strategy most appropriate for these fractions would be creating common numerators. In fact, we can see that the numerator of 2 is a factor of the numerator of 4. This means we can multiply 2/5 to create an equivalent fraction with 4 in the numerator. We will multiply it by 2. 2 multiplied by 2 is 4, and 5 multiplied by 2 is 10. The equivalent fraction we've created is 4/10. We can now compare the relative size of each fraction. 4 pieces that are 1/10 in size are smaller than 4 pieces that are 1/8 in size. Since 4/10 is equivalent to 2/5, we can reason that 2/5 is less than 4/8. The objective for this lesson was to compare fractions using appropriate strategies. We met this objective by reviewing 4 strategies for comparing fractions. We then identified which strategy best fit each pair of fractions. We also used some visual representations to prove our reasoning.